Go. All right, there's another way that we can write vectors, and that is using unit vector notation. So the unit vectors we are going to be using are I hat, j hat, k hat. I hat is a unit vector of length 1 in the x direction. J hat is length 1 in the y direction. And k hat is length 1 in the z direction. Now, it would be nice to say that every single textbook that we have uses this exact notation, but that would be a lie. In math books, you will commonly see x hat, y hat, z hat. You may also see x with a little vector, y with a little vector, and z with a little vector. I have actually had a time where I had 3 different textbooks the exact same semester with 3 different sets of notation that meant the same thing. This is what I'm going to be using. There is a 4th way we could also write this, and that's using this vector notation where this is the x term, this is the y term, and this is the z term. So there's other additional sets of notation. So before we get further into unit vector notation, we have to be able to break a vector into its components. If you have been in physics, if I have vector A, first thing I'm going to be doing is I'm going to be making a right triangle. So I'm going to draw up a perpendicular. I'm going to have a horizontal line. This is going to be my x component. This is going to be my y component. Now, if I have my angle, which is a standard angle from the positive x direction, I can find those components using sine and cosine. A sub x is going to be the magnitude of vector A, cosine of theta. A sub y is going to be the magnitude of vector A, sine theta. And yes, we write the length of vector A as either A with an arrow over the top or just A without an arrow at all. So another way to write vector A using unit vector notation would be to give the x component I hat plus the y component j hat. Probably wondering why we would choose unit vector notation. If I have 2 vectors, vector A, let's say vector A is 2i hat, 5j hat, and let's give it a little bit of a z direction. Let's give it, we'll say 2k hat as well. And vector B, let's say that's 3i hat minus 4j hat plus 6k hat. If I wanted to know what vector A plus vector B was, all I have to do is add like terms. 5i hat plus j hat plus 8k hat. If I wanted to know the magnitude of this, the magnitude of vectors A plus B, what I'm basically going to be setting up is a length equation. It's going to be like Pythagorean's theorem, except in 3D. So the x component squared plus the y component squared plus the z component squared square root. If I wanted to do subtraction, I'm going to take those same 2 vectors and let's say I wanted to do A minus B. Well, what I'm going to do is I'm going to go through and I'm going to make this negative B. I'm going to change all of the signs. So this is going to be negative I hat plus 9j hat minus 4k hat. Okay, so what if I wanted 2a plus b? What am I going to do? Well, I'm going to take 2 times the entirety of vector a. And then I'm going to add to that vector b. So I've got 4i hat plus 10j hat plus 4k hat. I'm going to add to that 3i hat minus 4j hat plus 6k hat. I tend to keep my vectors in parentheses just to keep my life a little cleaner. So I'm going to get 7i hat because I combine like terms, 6j hat, and 10k hat. So what I did right here, this is what's known as scalar multiplication of vectors. Basically, I take a scalar and it changes the length of the vector. So I just took the length of vector A by 2. And so each component is going to be adjusted. I'm going to write this in the notation we use in the section. This would be 7, 6, 10 with the pointy brackets. So, bring questions.